Let's start with the integrals of one variable function. We know how to find the derivative or the first derivative of the one variable function. And the geometrical meaning for the derivative, the first derivative is the slope of the curve represented by the function f of x. Now we are going to make the opposite way of the derivative, which is called in the integration or the antiderivative, right? So if you are given the first derivative, and we know, as example, the velocity is the first derivative of the distance with respect to the time. How we can get the distance? By integrating the velocity. But how to get the velocity? By differentiating the distance with respect to the time. This is a link between the derivative and the integration, or we call it antiderivative. We have two types of integrals. We have indefinite integral, so we don't have a boundary or limit for the integration from 2. And the other one is the definite integral. So we are going to integrate from, say, A to B. Okay. So what's the point of studying the integration? Maybe there are some application in engineering, physics, and different subjects. Okay, so the meaning of the integration giving you what? Giving you the area under the curve, right? The area under the curve represented by the function f of x. So when we're integrating this function from A to B, we get the area under this curve from A to B. Okay. The first way to know the integration, you know it as inverse process for the differentiation. We know the derivative of sine x is cosine x. So the integration of cosine x will be sine x. We know the derivative of x cubed over 3. You get the power down and subtracting 1 from the power. So you have 3x squared over 3. 3 will be cancelled with the 3. So you have x squared. This is a derivative. X squared is the derivative of this one. So the integration of x cubed over 3 is x squared. But the derivative of x cubed over 3 will be x squared. The integration of x squared will be x cubed over 3. So you add 1 to the power and divide it by the new power. We know the derivative of e to the x is e to the x. So the integration of e to the x is e to the x, right? So this is the first way of doing integration as inverse process of derivative, and we know we call it the antiderivative. Okay. This is a symbol and a notation you have to know. This is the notation of the integration of one variable function f of x dx. So we call this one the integral of f with respect to what? X, because I am integrating with respect to x, dx. Okay. What is the function f of x? The function f of x inside the integral, we call it the integrand, right? What about x? X is a variable I'm going to integrate with respect to. So the variable of integration is x, because I'm integrating with respect to x. Okay. What is the meaning of integrate? Integrate is a verb to find the integral. An integral of f is what? Is a function f which you are going to differentiate to give you f of x. Okay. Integration is the process of finding the integral. This is your vocabulary here for the integration. Constant of integration is a real number. We give it a notation c. Okay. Okay. Now, yes, I remember this table in the previous part, which was the differentiation calculus. We know the derivative of x to the n plus 1 over n plus 1. I get the power down, so it will be cancelled with the n plus 1. So I'm subtracting 1 from n plus 1, so the derivative of this one is x to the n. So the opposite side of the derivative, or the inverse process of the derivative, is the integration. So if I am integrating x to the n, I will get the stuff in the front of the derivative here. Okay, so how you can integrate x to the power n with respect to x? I am adding 1 to the power and divided by the new 1, and I'm adding the constant of the integration. Okay. Also, the derivative of x is 1. So when I'm integrating 1, here is 1, but we don't write it always. The integration of 1 dx is x plus c. And I know the derivative of sine x is cosine x. So the integration of cosine will give me the sine x. I know the derivative of minus cosine is minus sine, so to have sine x. So when I'm integrating sine x, it will be cosine. And you can follow this one. And we know the derivative of sine inverse x is 1 over root square of 1 minus x squared. Okay, and you can carry on for all of this one. Can you take a screenshot for this table, please, for yourself? And put it in the chat, please. Who is going to take the screenshot and put it in the chat, please? Because you are going to use this table in the next exercise, and I would like you to get familiar to how to integrate. Thank you. If I get the integration for 2x dx, yes, 2 is a constant, take it outside. The integration of x, I said I'm adding in 1 to the power, which is 1 here, so it will be x squared over 2. And I have already 2, so it will be cancelled, so I end up with x squared plus c. What is the c? I said this is a constant of the integration. Could be 1, 2, 3, minus 1, minus 2, whatever, right? But still, the function x squared plus c is a parabola, right? Once I change the c, I would still have the same different parabola, but with the same tangent, right? All of them having the same tangent at the turning point. Okay. Okay. Now, if you would like to differentiate the integration, I said the integration is the inverse process for the derivative, so they will cancel each other, exactly like the root square and the square. They are inverse process, so they cancel each other. So when you differentiate the integral, you end up with the original function inside. Okay, and of course plus a constant. Okay, this is very important. The derivative and the integration are inverse process of the integration, so they cancel each other, so you end up with f of x plus constant. Now, can we do this one using the table I let you take a screenshot from? The question here, write the antiderivative for each of the following functions using the method of inspection. I know how to find the derivative. Okay. So the derivative of sine 2x is 2 cosine 2x. I'm looking only for cosine 2x, so I divide it by 2. So I have this one. When it differentiated, I have cosine 2x. So the antiderivative of cosine 2x is half sine 2x. Also for this one, the derivative of x cubed plus x to the power 4 is 3x squared plus, so the antiderivative of 3x squared plus 4x cubed is x cubed plus x to the power 4. For the logarithm, I know the derivative of the logarithm is 1 over x when x is positive, And the derivative of log minus x when x is negative is minus 1 over minus x. So when I have a positive and negative and two sides, I have a V shape. This V shape is the absolute value of x. And so the antiderivative of log absolute value of x is 1 over x. This is boring to have the integration as anti-process or inverse process for the derivative. It is easy way to use this notation for the integration, okay, and find the integration. Yes, when I have two things here over one thing, so I can split them into the first one over this, the denominator, minus 1 over x squared, okay, and I will take the x squared up, it will be x to the minus 2, and I distribute the integration over the minus and the plus, okay. So I integrate x. How I can integrate x? Using your table, I add 1, so it will be x squared over 2, and here I'm adding 1, so it will be x to the minus 1 over minus 1, and I have minus, it will be plus, so I get this result. X to the minus 1 is 1 over x. It is easy way to do. Now, to integrate these two, I integrate the first part plus the integration of the second part. How to integrate x to the any power? I'm adding 1 to this power, so I will have x to 1 plus 2 over 3. It will be 5 over 3 over 5 over 3. And I have 1 here. So the integration of 1 is x to the power 0. When I'm adding 1, it will be x to the power 1 over 1. So this is the result. For the first one, as I said, you adding 1 to the 2 over 3. I have 5 over 3 and dividing by 5 over 3. So it will be 3 over 5. And I have 1, which is x to the power 0. When I'm adding 1, so it will be x to the power n over 1 plus the constant of the integration. Let's go for the last one. Also, I integrate the first one plus the integration of the second one and minus here the integration of 1 over x. It is easy to integrate this one, very similar to the one I have done it here. I'm adding 1 to 3 over 2 and dividing by the new power. 2, I take it outside, the integration of e to the x up to your table, it will be e to the x minus 1 over x. I know this one, this is the logarithm of the absolute value of x. So it is very easy to go through your table and you can know what is the integration of this function, right? Let's go for this example also. Also for the first one, I will going to integrate the sine x plus the integration of cosine x. Can you check in your table and tell me what is the integration of sine x?
Minus cosine x.
Excellent. What is the integration of cosine?
Sine x.
X. This is from your table, right?
Yes.
Yes. Let's go for the second one. This is a multiplication, so please multiply it first and then look at your table. So what I'm going to do, I'm multiplying the cosec times cosec, I will get cosec squared plus cosec times cotan x dx. Can you check in your table what is the integration of cosec squared?
Minus 10x.
Minus?
Cosec, yes.
Cosec squared, check it. Supposed to be cotan minus cotan x, right? Because in your table you have minus cosec squared. Multiply the minus, so you will have minus cotan x, right? Okay, what is the integration of cosec times cotan in the table? Please check in your table.
Minus cosec.
Minus cosec t. Yes, excellent. Very good. Now let's go for the third one. As I have done in the previous one, I split this fraction into two fractions because I have a common denominator here, right? So I have 1 over cosine square and minus sine square over this one. I know what is the inverse multiplication of cosine square x, which is 1 over cosec. It is sec square. 1 over cosine is sec. 1 over cosine square is sec square x. Sine over cosine square, I can make this one sine over cosine, which is tan. 1 over cosine is sec, right? So can you check in your table? Sec square x dx has
10.
integration equal to what?
10.
10.
Tan x. Excellent.
Tan.
What do you have for the integration for tan x sec x?
Sec x.
Excellent. So now you can use your table to have this one. Okay. Now we have exercise, right? Let's start together, and we have the board, and you will try to help me solving this one. Let's go for the first 5 questions. Now, what is the antiderivative of sine 2x? Antiderivative means what? The integration of sine 2x dx. Do you have it in your table?
Yes, cosine 2x over 2.
Yes, y cosine 2x over 2. I have in my table, I have sine x dx equal to what? Cosine x. But I don't have 2, right? So,
sorry, minus cosine.
Sorry?
Minus cosine 2x.
Minus cosine. Yes, yes. So when I having 2, I make like substitution. If I call it u equal to 2x, so I will have sine u, and for dx, du by dx equal to what? 2. So du will equal to dx. I have only dx, so dx will be half du, right? So this one will be half du, right? Now take the half outside, so the integration of sine u du is half sine u plus the constant. Get back to the normal. What's your u? U was 2x. I get u just to use the table. So I will have half sine 2x plus c. Okay. Now let's go for the next one. 2. The antiderivative of cosine 3x dx. In the table, I have only cosine x. So x or y or z, it doesn't matter. I have cosine z dz is equal to what? Sine z plus c. Integration of cosine Osama d Osama will equal to sine Osama plus c. It is just a symbol, right? I got it x, y, z, it doesn't matter, right? So what is the best way of thinking about this one? I'll go to the sine and I put the angle as it is and divide it by the derivative of the angle. You remember when I differentiate cosine 3x, I have it as minus sine 3x, and I multiply by the derivative of the angle, d by dx of the angle. So I'll have minus 3 sine 3x. This is how to differentiate. I multiply by the derivative. In the integration, I divided by the derivative, right? Okay, so I have to divide it by x. To check your integration, go to the opposite side. differentiate this result, right? Okay, of course, plus C. Differentiate your result, okay? If you have the function inside the integration, you will be right. So what I'm going to do to check my integration, I differentiate the result. If you differentiate this one, d by dx for sine 3x over 3 plus c. What is the derivative of sine 3x? Is cosine 3x multiplied by the derivative of the angle, which is 3 over 3. I cancel out this one. So yes, I get cosine 3x, which I call it the integrand. So I have the function inside. So my result is true now, right? Let's go for number 3. What is the antiderivative of e to the 2x? You got it now, right? Yes, it is e to the 2x divided by the derivative of the power. The derivative of the power, which is d by dx of 2x. So what do you have? E to the 2x over 2 plus the constant here. Easy? Let's go for number 4. What is the antiderivative or the integration? The same word. I like to use this notation. How to do this one? I know how to integrate x squared dx. I add 1 to the power and divide it by the new power plus a constant. I know this one. So if I get this one and I call it as x or as y, so if you call this one y equal to ax plus b, this is what we call it the substitution. So I would like to replace everything in terms of x to be in terms of y. So if I differentiate, dy by dx will equal to a. So dy will equal to a dx. Okay. Now my integration will be changed from a function of x, and the variable of integration is x, into a function of y, and dx is what? Dx will equal to 1 over a dy. 1 over a dy. 1 over a, take it outside, and you would like to integrate y squared with respect to y. As simple as that. 1 over a, and you add 1 to the power and divide it by the new one, but the constant 3. Now get back to your original variable. Okay, so this one will be a times 3 is 3a. Y cubed is ax plus b cubed plus c. This is how to do this one, right? Okay. Now, I'll give you a nice way to do this one. If you know what is the integration of x to the n dx, we know it. It is x to the n plus 1 over n plus 1 plus the constant, right? So if I replace x by any function of x, and I still have a power here, right? And also I am integrating this one. So when I have x here, I have dx here, the derivative of it. So when I have f of x, I'm supposed to have what outside? The derivative of this one. So it is f dash. So this is the generalization of this formula, right? So I will do the same at this one. And instead of x, I have f of x. And I'm adding the power, 1 to the power, and dividing by the new power plus the constant. This is the easy way to do, right? Okay, let's try. For example, I'll give you example here. 3x plus 2 to the power 5 dx. How you can do this one in terms of this one? This is my function f of x. So I should have outside here f dash of x. Okay, what is f dash of x? What is the derivative of 3x plus 2? It is 3. It is 3, right?
Yes,
so I need to have 3 over here, right? But I don't have, so I will write it down and I have it outside 1 over 3, just to, this one will be cancelled, so I didn't change in my question, right? This is the way to do this one, right? So straightforward, I have this formula, so I will have 1 over 3. What's my function of x? It is 3x plus 2 to the power 6 over 6 plus c. This is the easy way to integrate these things. Let's go for that number 5. What about the antiderivative, which is the integration of sine 2x minus 4e 3x dx? As I said, I will take it one by one. This integration can be distributed to the two things. So I integrate the first one. Minus 4 integration of e to the 3x dx. Again, I integrate normally. What is the integration of sine? It is minus cosine 2x, and I have to divide it by the derivative of the angle here. What is the derivative of this one? It's 2. Minus 4. What is the integration of e to the 3x? It is the same exponential function, and I have to divide it by the derivative of the power. What is the derivative of the 3x? It's 3. Now I finish. So I can write it down minus half cosine 2x minus 4 over 3 e to the 3x plus c. This is the easy way to do. Now let's go for the next, which is not different from the one we already have done. What is the integration of 4 e to the 3x plus 1 dx? Again, I'm going to distribute the integration, so I take the first part plus 1, plus integration of 1 dx. Now, if I have a constant, I'll take it the outside the integration. 1 times anything is x. Okay. Now, what is the integration of e exponential function? It is the same as the exponential function, and I have to divide it by the derivative of the power. What is the derivative of 3x? 3 plus. What is the integration of 1 dx? 1 is x to the power 0 if you like. So you can add 1 to the power and divide it by the new one. Okay. So this is 4 over 3 e to the 3x plus x plus c. This is how to integrate this one, right? Let's do number 7. What is the integration of x squared times 1 minus 1 over x squared dx? I don't know how to find the integration of multiplication, so I multiply first. Don't do this Don't do this. This is not equal to the integration of x squared dx times the integration of 1 minus 1 over x squared dx. This is completely big mistake, right? This is not equal to this one. So what I'm supposed to do, I multiply this one inside first, right? And then I will do the integration. X squared times 1 is x squared minus x squared times 1 over x squared dx. Now, this is x squared and this one will be cancelled to each other. So minus 1 dx. Now I can distribute the integration. So I can integrate x squared dx minus the integration of 1 dx. As I said, 1 is x to the power 0 if you like, right? And how to integrate x to the any power? You add 1 to the power, so it will be 3, and divided by the new power, minus, I add 1 to the power, so I'll have 1 over 1 plus c. So the integration will be 1 over 3 x cubed minus x plus c. Remember, this is not equal to, there is no distribution for multiplication over the integration, right? So you cannot distribute the integration over the multiplication or even over the division. Okay, so also the integration of, say, x over x plus 1 is not equal to dx, is not equal to x dx over the integration of x plus 1 dx. This is not equal. Okay. Now let's go for number 8. What is the integration of a x squared plus bx plus c dx? As simple as that, I distribute the integration over the addition or subtraction, no problem. So this is dx plus the integration of bx dx plus integration of c dx. A is a constant, so I will take it outside. B is constant, I'll take it outside the integration. C is a constant, I'll take it outside the integration. Now, what is the integration of x squared? I add 1 to the power and divided by the new power plus. What is the integration of x? I add 1 to the power, which is 1, so it will be 2 over 2 plus c. What is the integration of 1? As I said here is 1, or x to the power 0 if you like. So you have x to the 1 over 1. I cannot call the constant here c because I have already c here, so I can call it c1, okay, or any different notation. So 1 over 3 a x cubed, to write nicely, 1 over 2 b x squared plus cx plus c1. This is how to integrate this one. Now let's go further for this one. Nine. What is the antiderivative or the integration? The same question. 2x squared plus e to the x dx. Again, yes, I can distribute the integration over the addition. So 2x squared dx plus the integration of e to the x dx. Yes, the constant can take it outside. Now, if I look at my table, I know the power is 2, so I'll go for the integration of x to the power n. N is 2 here, so I am adding 1 to the power and dividing by the new one. And from the table, I know the integration of e to the x is e to the x over the derivative of the power, which is 1 plus c. So this one will be 2 over 3 x cubed plus e to the x plus c. Number 10. What is the integration of root square of x minus 1 over root square of x square dx? Yes, I have to expand this one, right? I will remind you, if you have x plus y square, this is called the complete square. How to do this one? The square of the first one plus, because I have plus over here. If I have minus, it will be minus 2, the first one times the second one, plus the square of the second one. This is a complete square. Let's do this one in this case. So the first one square minus, because I have minus. If I have minus here, this will be minus. If you have minus here, you have minus here. So what do you have? Minus what? Minus 2, the first one, times the second one, plus the second one square. Finish? Yes. I'll put bracket over here, dx. Now, yes, I know I can cancel out this one with this one, and I can cancel the square with the square root. I can cancel the square root with the square. So I end up with the integration of x minus 2 plus 1 over x dx. Now you can use your table to integrate x. You add to the power 1, so it will be 2 over 2 minus the integration of 2. If you would like to make in more steps, I will do it for you. So you can distribute the integration. So this is the integration of x dx minus 2, the integration of dx plus the integration of 1 over x dx. Now the integration of x, you add 1 to the power, which is 1 here. So it will be 2 over 2 minus 2. The integration of 1, which is x to the power 0, if you like. So it is x plus 1 over x from your table. It is the logarithm of the absolute value of x. Or I prefer to call it ln. Ln. The absolute value of x plus the constant c. Okay. So if you don't know how to expand the square, the complete square, you cannot manage this one right now. Okay, let's go for number 11. The integration of x cubed plus 5x squared minus 4 over x squared. Dx. As I said, I have the denominator here and I can slice this fraction, right? As I remind you, if you have 2 plus 1 plus 3 or plus 4 over 11, how you can write this one? Yes, you can write 2 over 11 plus 1 over 11 plus 4 over 11 because I have the common denominator here. So the addition will be easy for me. So I can add the numerator and I have the same denominator. I will do the opposite in this case, right? So now I have x cubed over x squared and I will have 5x squared over x squared and I have minus 4 over x squared. Now x cubed over x squared give me what? Give me x only, right? X squared will be cancelled with the x squared. I have 5 minus 4. If I get this one up, which is better for me, It will be what? Yes, as far as I know, x to the m is 1 over x to the minus m. Or I will give it to you straightforward. 1 over x to the power m is x to the minus m. So when you have things up, you change the power, the sign of the power. So it will be x to the minus 2 dx. Now I can distribute the integration, so I will integrate the first one plus 5, the integration of dx, minus 4, the integration of x to the minus 2 dx. How to integrate the x? I add the power to the power 1 and divide it by the new power, plus 5. This is 1 here, if you like, or x to the power 0, so it will be 5x. The integration of dx is x. Minus 4, I add 1 to the minus 2, it will be minus 1 over minus 1 plus c. I don't like to have a negative power in the numerator, so I can write this one minus will be plus 4 over 1 over x plus c. I like to write it down like here. Now I finish my turn. Here is your turn. I will stop recording and I will let you try yourself.